Hey Rubby,
Oh yeah?
I found this formula. Is this linear algebra or something else?
Oh, this is expression in Boolean algebra. Do you remember the lesson Mr. Sutai gave us yesterday?
Oh, I know. But I forgot how to use this expression.
Okay, let me teach you how to use this expression. So the expression just like this.
Oh, okay. I understand now. Let's make a YouTube video about this.
Yeah, of course.
Okay. Ngaturang panganjaliman. Om Swastiastu. Hello everyone. In this video, we will explain how to create circuit, use Karnaugh Map, create truth table, and simplify Boolean expression when given a problem.
Before we going to our lesson, allow us to introduce ourselves. Start with me. My name is Putra Artana with student ID 24151010 and then this is my friend.
And I'm Kadek Wahyu Ardia Putra with student ID 2415101002.
Now let's get straight into the material.
Okay, before tackling the problem, let me first explain what a Karnaugh Map is. A Karnaugh Map or key map is tool used to simplify Boolean algebra expression in digital circuit. It helps to minimize the complexity of the logic design by reducing the number of logic gates needed. This makes designing and implementing circuit more efficiently, especially and circuit become more complex in modern application. Okay, let's move on the first problem. Okay, this is a first problem. F, A, B, and C equals A times B plus A inverse times C plus B times C. Okay, F is output, and A, B, and C, this is input. Okay, A and B, this is AND gate. A inverse times C, this is AND gate. And the last one is B and C, this is AND gate. Now, let's see this. This is addition or plus. So this is OR gate, and this is OR gate too. Okay, now I will write two expressions in this problem. Okay, in this problem, we have three expressions. Is A times B, expression 1, expression 2, A inverse times C, and expression 3, B times C. Nah, A equals 1 and B equals 1. Why in here equals 1? Because this is not inverse. Okay, expression 2, this A inverse equals 0 and C C equals 1. Okay, expression 3 in this B equals 1 and C equals 1. Okay, now I will draw the Karnaugh map or key map.
Stranger.
Okay, this is a key map. Okay, let's see expression 1. And in expression 1, A equals 1 and B equals 1. So this key map in here. A equals 1, B equals 1, C nothing in expression 1. Okay, C equals 0. Okay, let's see the in expression 2, A equals 0 and C equals 1. A equals 0 and C equals 1 in here. Okay, let's see in expression 3, B equals 1 and C equals 1. So
Just crazy.
1 1 in here. Okay, this is a key map. Now I will write the simplify on this problem. 0 0 0 and 0. Okay, simplify. Okay, now let's see this key map. Okay, this is a block 1 and here is the block 2. Okay, in the block 1, the simplify is A 0 and C 1. So A inverse times C plus A1 A plus A plus B. Okay, because C changing to 0. Okay, this is a simplify in the problem. Okay, now I will draw circuit in this problem. Okay, input is A, B, and C. A, B, and C. This is the input. Now let's see this expression. In this expression, you have 3 AND gate. Now let's draw AND gate. Three AND gate and OR gate. This is the output F. Okay, this is a sheet kit on this problem. Okay, now I will draw the truth table in this problem. A, B, C, and output is F. Okay, before I write the truth table, you must remember this schema. Okay, the first I will take the block 1. Okay, A0, B and C 0. So A0, B0, C0. And the output is 0. Okay. So next, block 2, A0, B0, and C 1. A0, B0, and C1. And the output is 1. Okay, next, A0, B and C equals 1. 0, 1, 1. And the output is 1. Okay, next, A0, B1, and C0. 1, 0, 1. And the output is 0. Okay, next, in block 2. Okay, in block 2, A equals 1, B and C equals 0. 1, 0, 0, and the output is 0. Okay, next, A1, B0, and C equals 1, and the output is 0. 1, 0, 1, and the output is 0. Okay, next, A equals 1 and B and C equals 1. 1, 1, and 1. The output is 1. Okay, next, A equals 1, B equals 1, and C equals 0. 1, 1, and C 0 equals 1. Okay, this is a truth table in this problem. Okay, this is a truth table in this problem. Okay, now I will create a circuit in this simplify. Okay, in simplify we have expression A inverse times C plus A times B. Okay. Okay, in this expression we have two AND gate and one OR gate. This is the output. Okay, A inverse C Okay, this is a circuit in simplify. Okay, now I will create the key map in circuit simplify. Okay, in this expression, A inverse equals 0, C equals 1, plus A equals 1, B equals 1. So, A times C, A0 and C 1. Okay, in here I draw 1. Kelihatan nggak kamera gini ya? Aku sampai sini nulisnya. Kelihatan. Okay, in the and second expression, A times B, A equals 1 and B equals 1. So A here. Ini seharusnya sama kan ya?
Sama.
Gimana?
Kalau salah orang dari
Okay, this is a key map in simplify. Okay, this is a key map from simplify. Now I will draw the truth table from simplify. 0, 0, 0, 0. A0, B and C0, output is 0. And correct, 0. 0, 0, 0, output 0. Okay, A0, B0 and C1, output is 1. 0, 0, 1, 1. A0, B and C1, 1, 1. The output is 1. A0, B1 and C0, the output is 0. Okay, next. Okay, next. In the block 2, A equals 1, B and C equals 0. So 1, 0, 0, and the output is 0. 1, 0, 1, 1, 0, 1, 1, 0, 1, the output is 0. 1, 1, 1, A, B and C1, 1, 1, 1, the output is 1, and the last one, A0, B, A and B equals 1 and C equals 0. 1, 1, 0, and the output is 1. Okay, this is a truth table from simplify. From simplify. Okay, because the truth table of the expression from the problem and the truth table of the expression from the simplify are the same, so the result are verified to be correct. Okay, that's all from me. My friend will explain the next problem.
Hello my friend, my name is Putu, Rubby, Artana, and now I'm gonna explain the second problem. The second problem is okay, so this is the problem 2. From the problem, we know that F was a output, and then A, B, C, and D is a input. And then this is the problem that we gonna make the result of the problem. Okay, before we resolve the problem, we must to know about the gate of the logic gate. At least we must know about 3 of logic gate. The first logic gate is AND. AND gate is using for times or multiplication. And then the second logic gate is OR. OR gate is using for plus, and then the last logic gate is NOT. NOT is meant for inverse. So this is the 3 of logic gate that at least we should know to finish the problem of this expression. Okay, so the first step that we have to work to this expression is we gonna make this expression to be 4 expression. So I'm gonna make this problem to be four expression. The expression number one is AB. From expression number one, we know that there is two variable A and B, and then A inverse is mean for 0, and B is mean for 1. Because from logic gate we must using Boolean. So Boolean is like false and true, and then on and off, or maybe like this 0 and 1. Maybe 0 it means for off, and then 1 it means for on. So A inverse times B, it means 0 and 1. And then the second expression is A B inverse. For A is 1, and then for B, for B inverse is 0. And then the third expression is A C D. From this expression, there is three variable, and then all of this variable is 1 because there is no
Just crazy.
inverse.
Wahyu.
So A is for 1, and then C is for 1, and then D2 is for 1. And then the last expression is B C D. B is for 1, and then C is for 1, and then D is for 1. So we already know about the Boolean of the expression, and then we're gonna make the K-map of this expression. So after we already know about this Boolean expression, we're gonna make the K-map. And because we using 4 variable for this problem, so we're gonna make like 2 division. The division number 1 is A and B, then division number 2 is C and D. So for the left right is for variable B. For the left right is for variable A and B, and then for the top is for variable C and D. So there is 1 and 0. So there is 0, 1, and then so there is 0, 0, 0, 1, 1, 1, 1, 0. And then for CD, it's also like that. It's 0, 0, 0, 1, and then 1, 1, and then 1, 0. For the first of this equation, we know that A is A. So for this equation, for the left, 0 is for A, and then for the right is for B. So it means 0 A and then 0 B, and then this is also 0 A, and then this is 1 B, and then this is for 1 A and then 1 B, and then 1 A and then 1 B. And for the CD, it's also like that. For make the result of the K-map, I'm gonna making I'm gonna making the K map to be some division. The division number 1 is maybe like matrix. So there's a column and then there's a line, and then we're gonna clear the expression number 1. The expression number 1 is A inverse and B. A inverse is mean 0, and then B is mean 1. So every equation that means A0 and B1 is gonna be on or gonna be 1. And then from this K map, the A0 and B1 is just from this line, from line number 2. For line number 2 is A0 and B1. So it means all of this line is gonna on or gonna 1. So it's like this. And then the second expression is A, B inverse. It means A1 and then B inverse. It means B0. So this is just the only equation that A for 1 and then B for 0. So it means the line number 4 is all of this line is 1. And then we're gonna go to the expression number 3. For expression number 3 is ACD, and all of this variable there's no inverse. So ACD is all of this variable is 1. A1, C1, and then D1. So we're gonna find where in this variable, that means A1, C1, and then D1. From this variable, we already know that this is A1, and then this is also A1. And then from this variable, the CD1, I mean the C1 and D1 is only from this column. This column or the column number 3. So we're gonna take the AC11 and then A1. So it's from this area and then this also. But there is before we clear the ACD, it's already 1. So we don't have to change this for to be 1. And then for BCD, it's B1, and then this is also B1. And then we're gonna take the CD also from this line. So the answer is like this. So this is the K map of this problem. And then I'm gonna make a block of this K map. For the first block, I take all of this block. And then for the second block, I take this block. Because block at least have like 2 equations, so I'm gonna take this and this. So it's will gonna be like this. And yeah, this is the block of the equation number 2 of the K map. I mean, after we know the block of the K map, we gonna the circuit of this problem. I'm gonna erasing this equation. Then I'm gonna make the circuit of this problem. So now I'm gonna tell you about how to make circuit from the problem. First, we're gonna know there is 4 variable or 4 input and then 1 output. So we're gonna make the input first. The input is A, B, C, and then D. And then I already remind to when we solve the problem of expression, we're gonna using logic gate, and then logic gate, at least we has to know that there is at least 3 logic gate. The one logic gate is AND gate, is for multiplication, and then the OR gate is for addition or plus, and then for the last logic gate is NOT gate or for inverse. So from this expression, we already know that there is have 4 AND gate. 1, 2, 3, 4. So I'm gonna using like 4 AND gate, and then this is the symbol of the AND gate, like this, and then like this. And then all of this AND gate is connected by one OR gate. One OR gate, and then OR gate is gonna connect it to the output or the F. Okay. Now I'm gonna connect it the variable to the AND gate, and then connect it the AND gate to the OR gate. So the first expression is A inverse and then B to the first AND gate. Okay. So it's like this, and then this. But but I remind you to first expression A is inverse, so A is gonna be like this, and then this is the solve of expression number 1 or the first expression, and then we're gonna connect it the expression number 2. The expression number 2 is A times B inverse. For this A is connected like this to the AND gate number 2, and then for the B inverse, it's connected to expression number 2. So the expression number 2 and expression number 1, each only have 2 variables, A and B. And then for the expression number 2, the B is inverse. So the third expression is ACB. So the A is connected to AND gate number 3, and then the C also connected to AND gate number 3, and then the D is also connected to AND gate number 3. And for the last expression is BCD. It's like the equation number 3, but the A is not connected, but the B is connected. So the B is gonna go to expression, the last expression, and then the C is going to last expression 2, and then the D is going to last expression 2. Okay. I'm sorry because the connected is not good because I write it from the whiteboard only, from the whiteboard. So it's not that clear or not that good, but so yeah, at least the end gate is clear, and then we're gonna connect it all of this on end gate to this on gate, and then for this on gate we just gonna make like this. So the circuit of this problem is like this. Okay. Maybe after we write the circuit, I'm gonna make the simplify of this Karnaugh map. So the simplify of this Karnaugh map is I'm gonna tell you about how to make the simplify of this Karnaugh map. Okay. The simplify of this Karnaugh map, I mean, how to get the simplify of this Karnaugh map, we're gonna take all of this block to be a one equation. It's like block number 1, it must be have one equation, and then block number 2 it also have one equation, and then the block number 3 is also gonna have the one equation. And we're gonna clear the equation of block 1 first. So I'm gonna write to this area. Okay. All of this block is have one equation. The equation is A0 and then B1. You know, like from equation, the first equation, and then to the second equation, to the third equation, to the fourth equation, it's always A0 and then B1. So the first simplify is A inverse. Okay. So the first equation is A inverse and then B, because the B is 1. So this is the first expression. We're gonna go to the second expression. From second expression, we're gonna take the block number 2. The block number 2 is from the bottom. It's from the line 4. So from equation number 1 to the equation number 2 to the equation the third equation, and then to the fourth equation, 1 1 1 1 have the same equation is A1 and B0. So is A and then B inverse. This is the equation of this block. And then the last equation is from this block. From this block, we already know that the equation of this block is it has A1, and then CD1. So for the B it's not the question because the B from the line number 3, the B is 1. But for the line number 4, the B is 0. So the B must be not include to the simplify. So the simplified equation is A, C, D. And yeah, this is the simplify of this Karnaugh map. I think I'm gonna I'm gonna make the circuit of this simplify. Okay. From the simplify, we just have to take like this, okay, I'm gonna write from this area first. The simplify is A inverse B plus A B inverse plus A C D, and then I'm gonna make the circuit. So the circuit is at first we're gonna make the variable first or the input first. Okay, I'm gonna erase this line, and then the last variable is, or the last input is D. So this is the input. Just like the problem, it is 4 variable or 4 input, and then but this is only have 3 expression. For expression number 1 is A0 A times B. So wait, I'm gonna make the AND gate. So from this simplified expression, we already know that this is just have like 3 AND gate. AND gate number 1, AND gate number 2, and then the AND gate number 3. 3 AND gate. And then all of this AND gate is connected to one OR gate. One OR gate. Yeah. Now I'm gonna make connected all of this circuit from the first equation, the one equation first. A inverse B. So the A is connected to the first AND gate, and then the B also connected to the first AND gate. But from this area, the A is inverse. So I'm gonna make the inverse or the NOT logic gate. So this is the NOT logic gate. Is for it means A is inverse, and then the second AND gate is A times B inverse. A and then B. But the B is inverse, so I'm gonna make like this. And then for the last expression is just ACD. So the C is connected to the third, and then the C also, and then the A is also connected to this expression. So we have to clear the connection of input to the AND gate, and then we must to connect it all of this AND gate to the OR gate. So it's like this. Okay, so it's the connected all of the AND gate to the OR gate, and then the last is, of course, the OR gate gonna connect it to the output. So this is the simplify of this problem. I mean the circuit simplify of this problem. And now the last is I'm gonna make the truth table of this Karnaugh Map and then this simplify. From this simplify, it of course must be like this for the K map. A is first B, and then A B first, and then A C D. Why? Why it's same? Because we make the simplify from this K map. So of course, the K map of the simplify and this problem it's same. But the last objective that I have to tell to you is I'm gonna make the truth table of this problem and this simplify. And I'm gonna address it because this circuit is not important anymore. So I'm gonna make the truth table that's proof is the problem and the simplify is have the same result. So it means the simplify and then the expression of the f. So it means the simplify and the problem has same truth table, and then it means this is verified. Okay. Now I'm gonna write how to make the truth table, but maybe I'm gonna changing the this. So this is the input for the truth table. Now I'm gonna tell you how to make the output of this input or to finish the truth table. Okay. From this area, the input is from 0, 1, 0, 0. So it's from this area 0, 1, 0, 0 is 1. And then 0, 1, 0, 1 is 1. And then 0, 1, 1, 1 is 1. And then 0, 1, 1, 0 is 1. And I'm gonna stick to the block 2. The block 2 is 1, 0, 0, 0. So it's from this area. 1, 0, 0, 0 is 1. And then 1, 0, 0, 1 is 1 also. It's 1, 2. So the 1, 0, 1, 1. Wait. 1, 0, 1, 1 is 1. 1, 0, 1, 0 is 1, 2. And the last one is from this area. This area is 1, 1 and 1, 1, 2. So it's 1, 1, 1, 1, 1. Okay, so this is the output of the truth table. Right? Aku lihat dulu, memastikan benar ternyata aja.
Tinggal si 00 ya.
Yeah. So this is the output one of the truth table. And then how about else? The else of course is 0. So all of this equation except this one is 0. So from this from the equation is 0, 0, 0, and then this is also 0, and then this is 0, 0, 0. So this is the finish or the result of this problem. Yeah, I think we're gonna go to the inclusion from this material. So the inclusion is the Karnaugh Map is a powerful tool in digital circuit. It helps simplify complex Boolean expressions, reducing the number of logic gates required, and K-map are widely applied in various industries such as digital circuits, computer memory, communication system, consumer electronic, and automotive electronic.
Okay, that's all from us. Thank you for your attention. We close with Param Santi. Om Santi 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 Om.